Hello everyone. In today's video we're going to be discussing section 10.4, which is on inverses of functions. Our essential question is, how are a function and its inverse related? A function is just a relation that pairs inputs with outputs. Inverse basically means to undo, so an inverse relation or an inverse function is going to switch the inputs and the outputs or undo your original function completely. So our core concept is when we have a relation that pairs A values with B values, if A is your input and B is your output, we would have this ordered pair A comma B. The inverse is just going to switch those inputs and outputs. So all of your Y's go into the X spot and all of your X's go into the Y spot. So we end up with B comma A. So to find the inverse of each of these relations, all we're going to do is take each pair of inputs and outputs and swap their values. So this would be 7 for X, negative 4 for Y. My next would be 4 for X, negative 2 for Y. Then I have 1 for X and 0 for Y. Negative 2 for X and 2 for Y. And my last, I have negative 5 for X and 4 for Y. Looking at all of our inputs, I see that all of those inputs are different. So this is still a function. So this relation is the inverse of my original, and it is also a function. In B, we can write these as ordered pairs, or we can just swap them. I'll go ahead and write them as ordered pairs. So my input would then be 5, and my output would be negative 1. So we're swapping your inputs, which are X's, with your outputs, which are Y's. So now my X value would be 10, and my Y value would be 0. My X value would be 15, my Y value would be 1. X is 20, Y is 2. X would be 25, Y would be 3. And X would be 30, Y would be 4. So all we did is we swapped the inputs, or the X's, and the outputs, or the Y's. Go ahead and take a moment, pause the video, and try these two on your own. We would have negative 4, negative 3, 0, negative 2, 4, negative 1, 8, 0, 12, 1, 16, 2, and 23. And this relation is again a function because all of our inputs are different. In our second relation, my input would be a 4 and the output would be a negative 2 from this first set. Next, my input is 1, output negative 1, input 0, output 0, input 1, output 1, input 4, output 2. So this would be my set of ordered pairs, or my new relation, and this one is not a function because I see two repeated X values that give me two different Y values. To be a function, we have every X value paired with a different Y value. But here, I have X value paired with negative 1 and my same X value paired with a positive 1. So my X values are not all unique. The last thing we're going to talk about in this video is finding inverses algebraically. To find inverses algebraically, we're going to start the same way. We're going to start by switching your X's and your Y's. Now they're just in the form of an equation, so once we switch X's and Y's, we then go ahead and solve for Y. So for example, if I have the equation Y equals 3X minus 12, I would start by swapping the X's and the Y's, so every X becomes a Y, and every Y becomes an X. And then I just go through and I solve for my Y. So I'll go ahead and I'll add 12 to both sides. So X plus 12 is equal to 3Y. And then we divide everything by 3. X over 3 is going to stay X over 3. 12 over 3 reduces to 4, and that's equal to Y. So my inverse function y equals x over 3 plus 4. And this would be the inverse of my original equation. So we're going to go ahead and do that in example 3. Find the inverse of the function given. Well, this function is called f, so I'm going to go ahead and instead of using that f of x notation, I'm just going to use my y notation instead to make things a little bit less tricky. And then I go through and swap all the x's and all the y's, so the y becomes an x, and my x becomes a y, and then I solve. Add 9 to both sides. So x plus 9 is equal to 4y. And then I divide by 4 everywhere. On the left, if I divide separately, nothing's going to reduce. So we do have the option to have individual fractions or to divide everything as one big fraction. As long as everything is being divided by 4, that would be okay. So then y equals, I have x plus 9 all over 4. And the only thing I'm going to do from here is go back into my f of x notation. So I had f of x to start, I didn't have y. So I'm going to go ahead and write f of x is equal to x plus 9 over 4. And this f of x has a very specific relationship to your original function. And that is that this new f of x is the inverse of our original. So what I can do is use our inverse notation to tell people that this is the inverse. This isn't the original f of x, this is the inverse. So I go ahead and put a little -1 in between the f and the x, and that tells our readers that this is the inverse of our original f of x function. This is the function that's exactly opposite or undoes everything in your original function. Go ahead, take a moment, pause the video, and try numbers 6, 7, and 8 on your own. I'm going to start by writing this as y equals 6x. I swap my x and my y, and then I go ahead and solve for y by dividing by 6. So y is equal to x over 6. I go back into my f of x notation, and since this is the inverse, I include that -1. Number 7, y equals -x plus 5. Swap your x's and your y's. Solve for y. So x minus 5 is equal to -y. I divide everything by -1, and here I will keep separate fractions. So then I have just y is equal to -x plus 5. Go back to your f of x notation. And since this is the inverse, we go ahead and we use our inverse notation. Number 8, I go into y. I switch my x and my y. And solve for y. I start by adding 1. I can multiply by 4 to get rid of the fraction on the right, which means I need to multiply everything by 4. So 4x plus 4 equals y. Going into my f of x notation, this is my inverse function, so f inverse of x is equal to 4x plus 4. And this concludes our lesson on finding inverses of functions. Thanks so much for watching, and have a great rest of your day.